Oh, hey, what's happening, everybody? It's Brian House here for Housework, and today we are going to be drilling and tapping through some 1.5 inch by 1.5 inch tube steel that's structural, so it's a 1/4 inch thick on all sides. And the reason we're doing this is we're building a piece of the Revolution 2x72 belt grinder. If you're not following along with that project, I'll put a link right up here so that you can click through and see what that's all about. Essentially, it's a 2x72 belt grinder that was designed, prototyped, and ultimately led to manufacture right here on YouTube. It's a great story, I think, and if you click that like and subscribe button and click that little bell, you get a notification every time I upload something to YouTube. Now, the reason why I'm making this video, and I would normally never make a video about something as simple as drilling and tapping, but in this particular case, I get a lot of questions about, hey Brian, how do you actually get the threads to match up on both sides? And what kind of tap do you use? Are you using some sort of special long tap? And actually the answer to that question is no, I don't use anything special at all. In fact, today we're going to make this process happen using just my old Craftsman 13-inch drill press and just a drill vise and a couple other small, inexpensive tools that you probably already have laying around anyway. So the short of it is that what we're doing is we're making sure that when we put those threads through, that there will be a bolt or a knob that will be able to thread all the way through and not bind up on the way out. So you want to make sure that it goes all the way through. And yeah, essentially that's it. And you'll be surprised actually how quick and easy this can be achieved using some simple tools that you probably have in your workshop. Now, if you don't have a tap and die set, I went to Harbor Freight and just bought their cheapo tap and die set. Also, if you're just looking to drill and tap a particular size, I'm going to put links down in the description to Amazon where I buy any additional taps that maybe I've broken and I need to replace. I just buy them right on Amazon and they're pretty inexpensive. So there's links down in the description and you can go through and purchase one of those taps. All right, guys, let's get started on this project and make this happen. Now, one of the first steps of making this happen is to get your vise all set up. This is just a cheap Harbor Freight vise. There's nothing really to it. It's a drill press vise as far as I know. But you're going to want to lock it down, and you're going to want to lock it down so that the drill bit, when it goes through whatever you're working on, is the right height, number one. And then also that it can go all the way down and through, because if you set it up over here, and it's gonna run into a couple of things down there. So you just want to make sure you have the right clearance all the way through, and that you set your height so that your workpiece, which is going to be right underneath, right at this level of the vise, can actually go all the way through. You can see right now I'm hitting a stop. I can't go much further. So let me just go ahead and crank this up a little bit. Get this down like that. We don't need much. We just need to get through the workpiece all the way in one motion. That's just pretty important to me. All right, so now that we've got that done, I'm going to go ahead and lock this down on this table here. And that's really simple. There's a really simple way to do it. It's just a couple of bolts and a couple of nuts and washers, and we're going to lock this right straight down. Now, when you go to lock this down on the drill press itself, there's a couple of things you want to think about. My first initial instinct was to try to line it up like this. And, when you do that, you run into a few issues because this thing is the only thing that moves on this vise. So your workpiece needs to be somewhere right around there if you're going to be drilling into it, right? So when you do that, you only have a couple of points of contact on here, which is right about here. And to me, that just didn't seem safe enough. So I wanted to make sure I still had my clearance through here, but I also want to be able to lock this down and also kind of move it around a little bit if I want to. So on the diagonal, what that does is allows me to still turn this and work with the clearances that I need down in here, and then also be able to kind of shift things around and then lock it down. Now I have these 2 points of contact which are closer to the block itself. Now to lock this down, I'm just going to use some socket head bolts and washers and nuts. These are nothing really that special. I just have them laying around because I've been using them on the Revolution project. But you really want to make sure that you've got enough bite on those washers, okay? So when you put this through, these are 1.5 inches, by the way, so they're just enough clearance to give me a little bit of bite underneath with these nuts here. So, and again, we don't really want to lock this down until we fully know where the piece is going to sit and where we want it. So we're not going to tighten it down too tight. And it looks like I'm going to need a washer on the underside of this as well because it's going to slide through that slot. So I'm going to put a washer up underneath here. And in this particular case, I don't really feel like I need to have a lock washer in play because, again, this should shift around just a little bit. I'll lock it down temporarily, and then we will drill our holes and then loosen it back up so you can, modify it for a later project. All right, so this is our workpiece. This is what we're going to be working with. This is 1.5 inches by 1.5 inches square tube, and it's structural square tubing. That means that this is 1/4 of an inch thick all the way around. And there is a weld seam in here, so we really want to avoid that. That's something to think about. And what this is, in this particular case, and the reason why I am creating this video, is this is the tensioning arm that holds up the tracking wheel on the Revolution. Now, this project showing you how to tap using a drill press really is versatile. You can use it for a lot of other projects. But in this particular case, we want to tap all the way straight through, and we want to make sure those threads go all the way through and that they don't get bound up halfway across. So I get this question a lot, and I really want to help you all understand how I do this, because there's really just a couple of small tricks and no special tools to make it happen. So the first thing is we need to know where we want to drill our initial hole. And because we're drilling a 3/8 hole, we're going to tap that. We need to drill a 5/16 hole all the way through and in one motion. And in this particular case, because it's a tracking mechanism, it's 1 inch back. So I'm going to take my ruler and also my scratch awl, and we're going to make a mark 1 inch back, somewhere a little bit lower, because in this particular case, we're going to use this tracking arm is going to use the new tracking mechanism for the Revolution, which the hole should be drilled not center, but just south of center. All right, grab our ruler and our scratch awl. And again, we're going to avoid this weld seam, and I'm going to put it on the bottom. I'm going to measure back 1 inch. Okay, so we have our mark right there. And in this case, like I said, we want to go as far down as we possibly can. So I am going to make a mark right there. If I drill that out, I should have enough clearance to make it. And all the way through, punch a little bit, make a mark right here. And that's going to keep our drill press from wandering when we hit that mark. It's going to go all the way through. Okay, so let's, now that we've got the height set properly, we've got our vise bolted down, loosely bolted down to the deck, I'm going to go ahead and swap out the 5/16 drill bit here for a 3/16. And the reason why I'm going to do that is because I like to drill a pilot hole before I do any of this work. And of course, if you're real skilled and you know what you're doing, you can get away with not drilling a pilot hole. But because of the precision needed here, I like to just give myself the best chance to, put my best foot forward and make good decisions with my work, not rush through it. Because, hey man, if you do this, you set this whole thing up and you screw it up, then you got to cut a whole new piece, and it's just really not worth doing it a second time. All right, so here's our workpiece, and we're gonna set it in our vise, and we're gonna kind of line it up. In fact, I might turn it around this way. And we want to line it up so that we have enough room underneath this vise to allow the drill bit to go all the way through, okay? And I want it to give a nice bite in there, and I want it to sit flat as possible, all right? Lock it down, and you can see now, because I've got these bolts nice and loose, I'm able to manipulate this vise a little bit and figure out exactly where I want to go through this piece here. And I feel confident that I'm going to be able to line it up. It's a little bit more difficult than using my mill, but it's definitely doable. All right, so you can see we're right on top of that divot that we made with the scratch awl with the punch. And I'm going to take and hand tighten these two down right here. And then I'm going to grab my wrench and I'm going to make them just a bit more tight because I want to make sure that this does not move. This whole situation does not move. Now you can see we've got right on top. We've got our clearances set properly. We're going to be able to drill all the way through without hitting anything on the other side. One last thing I'd like to talk about is always using cutting oil or some sort of lubricant when you're making your initial cuts and taps. The stuff I use is Tap Magic. I'll put a link down below so you can find it on Amazon, but it's definitely worth the buy. It keeps your drill bits sharp and also allows you to just cut through steel much smoother and without noise, and it just keeps your drill bits lasting longer. All right, let's drill this thing. Okay, so now you can see we've got our pilot hole drilled all the way straight through, one motion, which is going to allow for us to tap in a straight motion when we get done with the actual tapping as well. So all the way through. Let's clean up our chips. I like to do that with an air compressor. It just goes pretty quick, a little bit of compressed air. Everything nice and clean. All right, now that we've got our pilot hole drilled all the way through, this is 3/16 of an inch. Let's go ahead and swap this drill bit out for a 5/16, and then we'll be ready to tap our hole. I get asked a lot about what kind of drill bits I use. This particular one, this 3/16, is a DeWalt from an old kit that I had. I like these. They work pretty great. They can get a little bit expensive, but my go-to is the Harbor Freight, the cheap titanium drill bits. For whatever reason, they just call my name whenever I'm in a Harbor Freight, so I end up buying them. And then I'm like, oh, should I have done that? Blah, blah, blah. And then, whatever. But I've been pretty happy with them, to be honest. And one of the reasons is that I have a drill doctor. And that drill doctor allows me to keep those drill bits sharp. I have a video in my library. You can go back and watch it, where I actually broke a drill bit in half and then used the drill doctor to actually make it a whole drill bit again. So they are... not the highest quality bits, but for what I do, and I've probably drilled 1,000 holes with this drill bit right here. It's just a cheap titanium Harbor Freight drill bit, and I love it. So, all right, let's make sure this is all lined up. Everything looks pretty good. It looks like it's just a little bit off. So I'm gonna go ahead, loosen this, put my drill bit down into it, hold it down, and then lock this in place. That way I know I've got everything kind of sitting proper here. A little bit of a wiggle there. Nothing too bad. Definitely a little bit more of a challenge in using my mill, but this can be done here. So what I'm looking for is, you can see the bit moving just slightly when I put it down into the pilot hole. It slides to the right there. What I'm looking for is, I'm trying to avoid that. I really want it to line up straight. It's possible that this drill bit is bent because I've used it so much. But in this case, I'm going to call this good, and we're just going to go ahead and drill straight through. Because we have a pilot hole in play, this bit should go straight through, no problem. Again, we're going to use Tap Magic on the bit itself. I like to drizzle just a little bit down into the flutes. My dad would always say, lubricate the tool and not the work piece. So, all right, here we go. All right, it's looking pretty good. I'm gonna use a little bit of compressed air to clean out the chips. A couple of little pieces in there. All right, nice and straight through, looking good. All right, so I'm gonna take the drill bit out of the drill press here. All the way through. I made that job easy. And I'm gonna take a quick look at my hole here. It looks really nice. A little bit of burring on the other side, a little bit of push through here, a little ridge. So I actually have a solution for that, which I really like. I'm using these single fluted chamfer bits. They're kind of like I don't know if it's like would be considered a countersink or what, but it cleans up edges like this, and especially if you're going to be, even like a nice clean edge like this one, even if you're going to be tapping or not tapping, it makes a really nice clean countersink hole there. So I'm going to go ahead and just take the edge off of each one of these. And believe it or not, I actually prefer doing this with the workpiece kind of loose. I've found that I'm able to get a better chamfer that way. So I'm going to go ahead and loosen this vise up. It's enough to get me where I need to go here. I want the workpiece supported. I don't want it in there too tight, because I want it to be able to self-center. We're going to just do a light touch with it and remove that burr. Also, we're going to use some Tap Magic. A bit of lube here. Nice, even, beautiful chamfer on there. All right, let's do the other side. Set this up nice and loose. Make sure it'll sit, go in where I want it. Lube this guy up. Lube around the outside. Just make sure my workpiece can move freely. Try to center it up as best as I can. That's what it peeled off of there. Beautiful, beautiful chamfer there. Ready for our tap. Man, I love that tool. I'll put a link down in the description so you can find one for yourself on Amazon. All right, so now we've got our hole drilled all the way through. This is a 5/16 inch hole, and we've got our nice chamfers on there. We're all set up and ready to go go ahead and tap this. Now, I'm gonna do something that I kind of came up with. This is, totally up to you. You can do this by hand, but in order to get a nice straight tap through this, I like to use just this cheap Harbor Freight center punch. They're about $3, and they're spring loaded so that when if you want to make a mark on something, it'll tap a mark into something. But what I like to use this for is actually a tap follower. And if you're not familiar with what a tap follower is, taps have a small indent down inside the top of the tap. And what that's for is if you want to try to line it up with something, you can use a punch, or a tap follower is the best way to do it. And this will help you align your tap with whatever you're in. So if you have a press or a tapping head for your mill or whatever. But you can actually modify this drill press to allow for this makeshift $3 tap follower. So first things first, we got to lower this this deck a little bit. We need some clearance, and then we're going to mount the my hole punch, or my center punch, in the chuck here. Gives us a little bit of room because we need to allow for enough clearance for the tap and the center punch here. A little bit more down. This doesn't need to be in there real tight, just enough to kind of seat it down in there. All right, so now we've got our tap follower, which is just our cheap Harbor Freight center punch. We're going to take the tap itself, and we're going to put it into the arm that turns the tap. I don't know what it's called. I'm a moron, so we're going to put it into the tap wrench. I have no idea what this is called. You can help me out with that in the comments if you want. Yeah, I have no idea. But anyway, this goes in here like this. Centers it up, and then down into the hole. And you can see we're not lined up. Okay, so we want to take this and we want to start lining this up. Now, because my drill press wants to spring back, I have I keep a spring clamp handy so that I can actually lock my press down. Just put the clamp up on the top and it locks it in place. So let's go ahead and line this up as best as possible. Get it in there. You can hear it click into place. Okay. And then for this kind of operation, you can eyeball it. You can do your best to kind of, get everything where it needs to be lined up. But in a mill, this is much more simple. Okay. But in the drill press like this, you're really going to want to, maybe grab yourself a square or something to kind of assist you in this process to make this happen. The reality of it is that this tap needs to be 90 degrees off the top on both sides. And if you don't do that correctly and you don't have it lined up, you're going to have a real hard time making this an accurate tap. So just something to think about here. And the reality of this is that you need this to be lined up only for the first couple of threads. Once you have those first couple threads threaded down and through, and it's lined up, you can remove the tap follower because you're not going to be able to adjust it one way or the other anyway, so it won't really matter. Now, I have these 1, 2, 3 blocks, and they're super helpful because they're 90 degrees, so I can take these and I can line them up and see if everything looks straight. It's pretty close. Looks good that way. Don't have a lot of clearance on this side. But we can line it up that way. It looks pretty good. Okay, so now I feel like I've got everything lined up. I'm fairly confident that this is, you know, it's not going to be perfect, but it's close, right? And one of the first things we want to make sure we do is lubricate all cutting surfaces on the tap so that you got plenty of oil. And these first couple of turns are really the most important turns of the entire tap. If you can get these turns correct, then your tap will go through straight. So we're going to go ahead and start cutting into our steel, and we're going to just take these, you know, turns as they come. And if you start feeling any resistance in the steel, you're going to want to back off just slightly like this and break off those pieces that are causing resistance. I've broken a lot of taps, and you know, that's okay, but it's a huge pain in the butt. Usually you end up having to drill it out and start over. It's just a time suck. So, you know, these first couple, just make sure you get them nice and sunk in there and turning, and you can see I'm backing it out. I'm not just forcing the tap through the steel. I'm just loosening everything up, making sure it'll go through. And as I feel resistance, I'll back it out, and those pieces will kind of come free and allow me to keep cutting. And at this point, you can pretty much remove this situation. I'm just going to unlock that and disengage that because we're not going to be using that. In fact, I'm going to go ahead and get it out of my way here by removing it. It's just not necessary any longer. In here, and now I feel, yep, I'm all the way through. So at this point, I'm turning it and backing it in and out, turning it and backing it in and out. Okay, and what I also like to do is take a little bit of compressed air and blow my chips out and clean off the tap itself. Turn it, clean it off again. And what you'll find is if you can keep your tap clean as it's going through, it's going to make a nicer cut, and it's not going to bind up as much. So feel free to clean as you go. All right, so now we're getting to kind of a critical point in this tap because we are going all the way through, and we want those threads to match up. You'll see that we just barely have enough for the tap down below to start grabbing before we run out of threads on the top. And what's really important at this stage is to make sure you keep pressure on the tap itself, on the top, so as it starts to hit that bottom piece of steel down there, it's going to seat properly and start tapping right away. I can feel it grabbing. And now we're tapping down below. Give you a little bit better view there. So now we're continuing to tap. One thing you really want to make sure you've got everything kind of locked down. You know, this clamping system should be locked down. Your table should be fairly locked down because you are putting pressure on all of this. And if you feel like you need more tap magic, you can add more. I think my piece is thoroughly soaked here. I feel it going in and through. And I think, yep, we're all through. And at this point, a little bit more compressed air. Blow those chips out, turn your tap, and then blow some up through bottom. And I like to go as far as I can. That tap, get those threads nice and solid. And then I'm going to back this out. And you'll see when I start backing it out, oh, you got some more chips there. So we're backing it out. We want it to come in one fluid motion. And there it comes. And again, clean your tap. It's a beautifully tapped hole all the way through. Now we can check this to make sure that everything looks right by threading a knob all the way through, just to see if we're successful. So I've got our knob here, and this will tell us if we did it the right way. It should thread all the way through, and it should not bind up at all. Looks good. It's coming through the other side. Give it one more try here. Thread it all the way through. When it hits those bottom threads, it slows down just a little bit, but no big deal. All the way through. All right, well, there you have it. This is a perfectly tapped 3/8 16-inch hole, and goes all the way through and threads all the way through without binding. This is something that you could apply these same techniques to just a simple single hole tap too, by the way. So I hope you learned something today in this process. I like to take my time when I tap something, just because the process can get a little bit touchy at times, and these little tiny techniques like blowing the air over the tap as it's going through, or using tap magic or some sort of cutting oil, all of those little things matter in my opinion. If you want a really good solid tap, those are the things that you're going to want to do to make this work. Listen guys, if you got something out of today's video, make sure you hit that thumbs up button, and if you're not already subscribed, hit that subscribe button, and if you click that little bell, you'll get a notification every time I upload something to YouTube. There's many ways to support my channel, and by far the best way is to go to my website, housemade.us. You can buy the plans for the Revolution. You can buy pieces and parts and kits. We ship to Europe. We are working on shipping to Australia and also to Canada at the moment. So those will all be on the forefront in the next few months. And as always, guys, I truly appreciate you hanging out in my workshop and studio and supporting me through Patreon and Buy Me a Coffee. Those are all ways to ensure that I can continue creating content. Again, guys, I appreciate you. I hope to see you on the next video. My name is Brian House, and this has been Housework.